Today I will be discussing the impact of livestock production on future global freshwater shortages. Of the freshwater withdrawn from the world each year, 87% is consumed by agriculture alone, and 29% of this amount is related to the production of animal products, the majority of which is used to produce livestock. It is well recognized that the production of animal products is water intense. However, the total impact of the livestock sector on global freshwater shortages has been given little consideration. If we consider the amount of water consumed directly by livestock as drinking water relative to the total amount of water used in agriculture, the figure is small. However, if we consider the total amount of water used in the production chain, which includes the amounts of water required to grow feed for livestock and depleted by pollution associated with the production of livestock, the water requirement becomes much larger. Furthermore, if we recognize that this water requirement is projected to increase drastically due to a rising food requirement for the growing human population and a shifting trend in global consumption of animal products, it is clear that livestock production is a significant contributor to future global freshwater shortages. In order to understand the future implications on water shortages, I will first give you an overview of the current impacts the livestock sector has on limited freshwater resources. I will then give you a definition of water footprint calculations. Current overextraction of freshwater resources for crop livestock systems has already resulted in falling groundwater and lake levels, decreasing river flows, water depletion due to pollution, and deteriorating wetland systems. Water stress related to livestock production is occurring worldwide. One of the most serious cases is in Botswana, a country where groundwater accounts for 65% of the total water available. The recharge rate of aquifers where groundwater is stored ranges from over 40 millimeters per year in the extreme north to little more than 0 millimeters in the central and western parts of the country. The water supply to livestock is obtained through the drilling of boreholes. To provide for the increasing number of grazing livestock, many ranches in the Kalahari Desert region have installed more boreholes than they are allowed. In the year 1990, the total water abstracted from aquifers was 76 million cubic meters. This exceeds the natural recharge rate of groundwater by 760%. In river basins such as the Blue Nile, which currently contains 58 million tropical livestock unit, water shortages are also highly evident. Agriculture is responsible for approximately 75% of the freshwater withdrawn from the Nile, much of which is used for the production of livestock. Moreover, in southwestern France, the irrigation of maize for feed has been held responsible for severe drops in the flow of major rivers during summer droughts. The total amount of water used in the production of livestock is measured by a water footprint calculation. Water footprint is a metric that is used to measure the total volume of fresh water used to produce the goods and services consumed by an individual or a community, and quantifies the potential environmental impact related to water. The total water footprint of a product consists of three components: green, blue, and gray water footprints. The blue water footprint measures the volume of surface and groundwater consumed, generally by evaporation after withdrawal as a result of producing the product. The rainwater consumed is the green water footprint, and the volume of fresh water that is required to assimilate the load of pollutants based on the ambient water quality standard makes up the gray water footprint. The majority of water used within the production chain of livestock is the growing of feed. To produce 1 kilogram of beef, approximately 100 kilograms of hay forage and 4 kilograms of grain are required. Additionally, 105,400 liters of water will be needed to produce this much plant biomass in grain. Grain is the most water-intensive type of feed for livestock. Under rain-fed and favorable climatic conditions, it requires 1,000 to 2,000 kilograms of water. In an arid country, the water requirement to produce the same amount of grain is almost double. Due to the high temperature and high evapotranspiration in arid countries, 3,000 to 5,000 kilograms of water are required. Along with the fact that livestock production requires a large amount of water to grow feed, it also causes water depletion due to pollution. Most of the water used by livestock, whether for drinking and servicing or growing feed, returns to the environment. While a portion of this water may be reusable in the same basin, other portions are polluted by excreted drug residues and heavy metals, which are used as supplements for livestock, or by nitrogen and phosphorus from fertilizers. These pollutants reach water systems by way of leaching, surface runoff, subsurface flow, and soil erosion. Although the total volume of water depleted by pollution is not quantifiable, it is still evident that the livestock sector is a major contributor to water depletion due to pollution. In support of this argument, researchers have found that in the United Kingdom, the livestock sector is the leading contributor to water pollution from mineral fertilizers. Nitrogen and phosphorus from agricultural land used for feed, pastures, and rangelands is responsible for a third of the total depletion of surface water due to nitrogen and phosphorus pollution in the United States. Although purification of polluted water is possible, it is extremely costly. An estimated US $10 per kilogram is required to remove nitrates from drinking water, totaling US $29.8 million per year. Because of the water required to grow feed and the water depleted by pollution, it is actually more efficient to obtain calories, protein, and fat through vegetable products than animal products, as the water footprint of animal products is larger than the water footprint of vegetable products with an equal nutritional value. In terms of calories, the average water footprint per calorie for beef is 20 times larger than for cereals and starchy roots. For protein, approximately 100 times more water is required to produce only 1 kilogram of animal protein than 1 kilogram of vegetable protein. Regarding fat, although butter has a lower water footprint per gram of fat than oil crops, all other animal products have larger water footprints per gram of fat in comparison with oil crops. The production of livestock already has a large freshwater requirement due to the water required to grow feed and the water depleted by pollution. In the future, because of projected increases in human population and the consumption of animal products, even more water will be used, contributing to global freshwater shortages. Freshwater resources are rapidly declining as the needs of the growing population increase and will continue to decrease as the human population expands. The increasing food requirements to feed future generations will put enormous strain on already limited freshwater resources. Currently, more than 2.3 billion people in 21 countries live in water-stressed basins, and 1.7 billion people live in basins under scarcity conditions. The human population is projected to increase by 65%, which is 3.7 billion people by approximately 2050. In conjunction with population growth, food demands are estimated to increase by 70 to 90%. This will require an additional 5,000 to 6,000 cubic kilometers of water per year, compared with the 7,000 cubic kilometers currently required for today's yearly global production of food and feed for livestock. Since the majority of human population growth and agricultural expansion is taking place in developing countries experiencing a shift in diet towards animal products, much of the food required to feed future generations will be animal products. Over the last few decades, global meat production has almost doubled between 1980 and 2004, and is projected to rise more than 50% over the next 25 years. By the year 2020, it is expected that livestock will likely produce more than half of the total global agricultural output in monetary value. Urbanization, growing economies, and rising individual incomes are identified as causes of the global shift toward the consumption of animal products such as meat, milk, and eggs. This shift is especially apparent in developing countries where the consumption of meat and dairy products have been increasing by 5 to 6% and 3.4 to 3.8% annually, respectively. For example, between 1978 and 2006, Chinese rural and urban residents' per capita consumption of livestock products have increased by 225.8% and 126.2%, respectively. In conclusion, the production of livestock currently uses up a large amount of already limited freshwater resources in the growing of feed and water loss from pollution. In the future, these water losses will increase because of the projected increase in food required to feed the growing human population and the global shift toward the consumption of more animal products. When combining all of these factors, it is clear that livestock production is a significant contributor to future global freshwater shortages. Although it is inevitable that livestock production will have some impact on the availability of freshwater resources, it is possible to reduce this impact by critically looking at how the growing demand for animal products and the techniques used in livestock production can be modified. Researchers suggest that government environmental policy could influence both the production and consumption of animal products. As the growing of feed is the heaviest consumer of water along the production chain, adopting water-conserving farming techniques could also help reduce the water footprint of livestock production. Examples of water-conserving farming techniques are using drip irrigation systems, irrigating at night, and planting trees to serve as shelter belts. All of these strategies reduce evapotranspiration and increase irrigation efficiency. I would like to finish by saying that you have the opportunity to aid in conserving water by consuming less animal products. Thank you.